Assalamualaikum and hi. Today we're gonna go into a study case about a material involved in bicycle for material science, and we are from group 4. And this is our group mates. Our group mates are consist of 4 people. That is me, Muhammad Danish Armail bin Armanizam, and we got Muhammad Azri bin Buhari, Muhammad Akmal Hazim bin Hazuli, and Muhammad Amir Ashraf bin Muhammad Akbar. Okay, in the first of all, we're gonna continue with the introduction of our case study. So, material science is the key of the bicycle design, performance, affecting the strength, weight, durability, and efficiency. This case study examines the 4 components: the tire, frame, gear, and the chain system. And the pedal of each requirement materials are with specific mechanical and chemical properties. Tire must offer grip and flexibilities. For frames, needs to be strong yet lightweight, and for gears and chains require high fatigue and corrosion resistance. And the pedals must be durable under repeated loads. Understanding these material choices highlights how materials engineering improve bicycle safety, efficiency, and user experience.
Okay, for this project, I choose frame bicycle. The material is aluminium alloy 6061. The code ASTM B221. The properties: high strength to weight ratio, corrosion resistance, highly recyclable, and lightweight. For the new material proposal, I choose Chromley steel AISI 4130. The properties is resist permanent deformation during normal loading, withstand repeat pressure, more dense than aluminium, easy to weld, and recyclable. Now we move to the impact analysis. The product used: aluminium frame is used in bicycles which rely on human power of movement, long lasting, reduce resource consumption, reduce dependence on motor vehicles. For the manufacturing, aluminium is machined, welded, and formed into bicycle frames in factories using precision tools and skilled labor. Uses a lot of water and electricity, produce dust and industrial waste. The raw material extraction: bauxite is mined in open pit mines involving large land clearing and excavation, causing erosion, water pollution, and dangerous red mud waste. The material processing: workers refine bauxite into alumina and convert it into aluminium through high temperature electrolysis. High CO2 emission and chemical waste, thermal and chemical hazard to workers. And for the disposal, the aluminium frame can be scrapped and recycled or improperly discarded. Recycling saves 95% energy and creates jobs. Its discard contributes to landfill waste and loses economic value.
So I continue with the material identification and analysis for bicycle tire. And for the material of the bicycle tire is gonna be rubber compound with potential synthetic reinforcement. So the code is ISO 4223-1. So the properties of this bicycle tire is high abrasion resistance, good flexibility and elasticity, and good for weather and chemical resistance, and damping or vibration. For the new material proposal, I would like to supply thermoplastic elastomers or TPE. Then the code is ISO 18064, and its property is for recyclable compared to the vulcanized rubber. It is lower energy required for processing, and resistant to UV and wear and moisture, can be reshaped and reprocessed, lighter and safer for the environment. Next, we continue to impact analysis. For the first one is product usage. The bicycle tire are essential component for mobility, enabling bicycle to operate efficiently on various terrains. And the environment and social impact is no fuel or emission during use and reduces reliance on motorized transport. The next one is manufacturing. Tires are manufactured using a rubber compounding vulcanized and more processed in specialized factories, and the environment and social impact is going to be a high energy use for curing process, emission of violating organic compounds, and occupational exposure to chemicals and fumes. The next one gonna be raw materials extraction. Rubber, natural or synthetic, is harvested from rubber trees or derived from a petroleum-based processes. Natural rubber land use change and biodiversity loss, and child labour is concern in some rubber plantations. So the next one is material processing. Rubber is refined, mixed with fillers and chemicals, then cured through heat treatment to form durable tires. Chemical waste generation, high temperature processes consume energy, and workers exposed to sulfur compounds and accelerators is for the environment and social impact. For the next one is end of life or disposal. The bicycle tires can be retreated, repurposed, recycled into such as playground surface or landfill. And the environmental and social impact is recycling reduce landfill volume and save resource. Improper disposal contributes to rubber waste and fire risk.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal Hazim bin Hazuli, and my matrix number is AA240504. And now I will discuss about one of the component in a bicycle, which is gear and chain. The existing material for gear is low alloy steel. The code is AISI 4140. For the change, the existing material is high carbon steel. The code is AISI 1085. The properties of this material is, for the gear, it have a high tensile strength, excellent wear and fatigue resistance, and moderate corrosion resistance. For the change, it also have a high tensile strength, high surface hardness, and also excellent wear and fatigue resistance. Next is impact analysis. There is 5 stages, and the first stage is product usage. The description is, gear and change of a bicycle are two critical components that transfer power from the rider's leg to the wheels. The environmental impact is no emissions during use, improved cycling efficiency and energy transfer. The next stage is manufacturing. In this stage, typically involves metal cutting, forming, and assembly processes. The impact is requires significant electricity and water that may produce industrial waste and noise. The third stage is raw material extraction. This component made mainly from steel, which comes from iron ore mining. This activity can damage ecosystems and also affects nearby communities due to land use and pollution. The next stage is material processing. Metals are melted, shaped, and treated to form durable components. The impact to the environment is produces greenhouse gases. This can risk of air and water pollution if unmanaged. The last stage is disposal. Worn gears and chains are often replaced and can be recycled. The impact is recycling reduces metal waste, but improper disposal can lead to landfill pollution. Next part is new material proposal. I will propose new material that generally is eco-friendly, which is recyclable with appropriate properties and suitable for this component function. So the new material for gear is aluminium alloy 7075T6. The code is ASTM B209. And for the chain, AISI 420 stainless steel. The code is ASTM A276. The properties of this new material is, for gear, it's recyclable aluminum. It have a very high strength to weight ratio and also have a corrosion resistant. For chain, it's fully recyclable, have corrosion resistant and can be hardened.
My name is Muhammad Miasra bin Muhammad Akbar. My matrix number is AA240040. Today I will discuss to you all about the material identification and analysis of the component of bicycle pedal. So the component is the bicycle pedal and the material is acrylonitrile butadiene styrene and the code is ASTM D4673. The properties of this material is it is lightweight and impact resistant. The second one is it is moldable into complex shape. And the third one is cost effective for mass production. And the last one, it is water and corrosion resistant. Okay, and then for the new material proposal, I choose recycled nylon 6 PA6. The code is ASTM D4066. The properties of this material is it is high impact resistant, it is tough and flexible, not brittle like some bioplastic. And the third one, it is recyclable multiple times. And the fourth one, it is thermal resistant, suitable for heat and friction during cycling. And the last one is it is sustainable source from post-consumer or industrial waste. Okay, for now I'm going to discuss about the impact analysis. Okay, there is 5 stages of the impact analysis. Okay, for the first stage, it is product usage. Description of the product usage is the pedal transfers power from the rider's foot to the drivetrain. It is made from lightweight and durable PA6. Okay, the environmental and the social impact. So it has no emissions during use. It is lightweight and long lasting, which will reduce needs for frequent replacement. Okay, second stage is manufacturing. The description is nylon is heated, melted, and injected molded into shape. Okay, the environmental and social impact is thermoplastic processes produce minimal waste and it has lower emission than metal manufacturing. Okay, the third stage is raw material extraction. So the description is the description is recycled PA6 comes from post-industrial or post-consumer plastic waste. So the environmental and social impact is use oops, it reduces dependence on petroleum-based virgin materials and it diverts plastic waste from landfills. Okay, the fourth stage is material processing. Description is plastic waste is cleaned, processed, and melted before reshaping. Okay, the environmental and social impact is it uses energy but significantly less than processing virgin materials. Okay, and it has risk of air and water pollution if unmanaged. Okay, the last one is disposal. The description is pedals can be recycled again or disposed of if damaged. So the environmental and social impact is it can be recycled if properly sorted. And improper disposal contributes to long-term landfill pollution with the non-biodegradability of it.
Next, I will discuss about the impact comparison between existing and new materials. So I will talk about the advantage and disadvantage for the existing and new materials. Right, for the first one is bicycle frame. The existing material is aluminium alloy 6061. The advantage is lightweight, corrosion resistant, recyclable and good strength to weight ratio. The disadvantage, high energy use during extraction and processing, produce fine dust and industrial waste, and also fatigue resistance. For the new material, which is chromoly steel, the advantage is fully recyclable, easy to weld, withstand repeated pressure, and more dense than aluminium. The disadvantage, heavier than aluminium, can corrode if uncoated, and also more complex processing. The next material is bicycle tire. The existing material is rubber, compound with potential synthetic reinforcement. The advantage of this material is it have a good flexibility and elasticity, high abrasion resistance and damping vibrations. The disadvantage, difficult to recycle, non-renewable resource and high energy use for curing process. The new material is thermoplastic elastomer (TPE). The advantage is fully recyclable, resistant to UV, wear and moisture, and also can be reshaped and reprocessed. The disadvantage is less durable in extreme condition and needs additive. The third component is gear and chain. The existing material is low alloy and high carbon steel. The advantage, high strength and durability, excellent wear and fatigue resistant, and cost effective. The disadvantage, high electricity and water used during manufacturing process, heavy and also prone to rust. For the new material, which is aluminum alloy 7075T6 and AISI 420 stainless steel. This new material advantage is fully recyclable, corrosion resistant, lighter, and can be hardened. The disadvantage, higher material cost, and also aluminum may wear faster. The last component is bicycle pedal. The existing material is acrylonitrile butadiene styrene. The advantage is lightweight and moldable, low production cost, water and corrosion resistant. The disadvantage is release valves during molding, non-biodegradable, non-renewable resource, and also emits toxic fumes if burned. The new material is recycled nylon 6 (PA6). The advantage of this material is recyclable multiple times, thermal resistance, high impact resistance, and also tough and flexible. The disadvantage is slightly more costly than virgin ABS and also may absorb moisture if untreated.
Now, we move to the new material impact analysis. For bicycle frame, chromely steel, raw material extraction, iron ore mining causes deforestation, water and soil pollution. The material processing, high CO2, emission from coke ovens, intensive energy use. Manufacturing, welding, cutting and forming processes using heavy and electrical equipment. For product use, encourage long-term use, support an active lifestyle. Durable and sturdy frame does need to be replaced. And for disposal, fully recyclable, energy saving compared to new production. For bicycle tire, thermoplastic elastomer (TPE). The raw material extraction derived from petroleum but does not involve sulfurization, less toxic. The material processing, TPE production uses low temperatures, less chemical emissions. The manufacturing, injection molding of tire shapes using minimal uses minimal heat, less carbon emissions, less noises and gas pollution, safe for workers. The product use, lightweight tires make it easier for users, increase cycling efficiency. And for the disposal, can be melt and reprint repeatedly. Support upcycling, innovation and local recycling economy. Next, for the aluminium alloy 7075 T6 for gear and AISI 420 stainless steel for chain. The raw material extraction, surrounding communities may experience health and environmental disruption. The material processing, electrolysis process AI 7175 and electric furnace still use high energy, high industrial safety risk, especially heat and chemicals. The manufacturing, high precision machining process such as milling and drilling produce metal waste, requires skills training, creates job opportunities. The product use, strong, lightweight, and rust-proof. Less wear equal to less displacement. Improve user experience and low maintenance. For the disposal, high market value, easy to recycle without losing properties, supporting a sustainable recycled metal sector. And the last is bicycle pedals, recycled nylon 6, PA6. The raw material extraction, use consumer and industrial waste, reduce plastic pollution, promote awareness of waste separation and reuse. The material processing, low energy, VOC release if not controlled. Good ventilation required for worker safety. The manufacturing, pedal shape injection molding, energy saving compared to metal. Fast and efficient process. Suitable for mass production. The product use, suitable for high friction, less risk of breakage. Durable pedals provide user satisfaction. And for the disposal, can be recycled several times. If burned, toxic. If recycled, reduce landfill burden and open up new industrial opportunities.
Okay, now I will go through this part, which is the implementation plan for new material in bicycle components. Okay, first for the first component, we go to the pedal, which is the recycled nylon 6, which is the PA6. Okay, so for the first part, we will source recycled nylon 6 pellet from certified suppliers, and then we will dry the pellets to remove moisture. It is important to remove bubble during molding. And the third part is we use injection molding to shape the pedal component. And then we add texture, surface, or grip insert for user comfort. And the last one is we assemble with axle and bearing. Okay. The second component is the gear and chain. Okay, which is the fiber reinforced biopolymer composite. So for the first step is we will select suitable biopolymer matrix and reinforcing fiber such as glass, carbon, or natural fiber. Okay, and then the second part is compound the composite using extrusion. Okay, and the third part is use compression molding and precision CNC machining to form gear and chain link. Okay, and then we perform finishing treatments for wear resistance. Okay, the last one is assemble chain with pins and lubricate it. Okay, thanks. Okay, so we'll go to the third component, which is the bicycle tires, which is the thermoplastic elastomer TPE. Okay, for the first step, we will formulate TPE compound with desired softness, rebound and grip, and then we extrude the TPE into tire shape with a blow molding or compaction molding. And then we will integrate with a fabric or mesh layer for reinforcement. And then for the fourth part, we will mold thread pattern for grip. And the last part, we will bond the tire with rim using mechanical locking and adhesive method. Okay. For the last component is frame, which is the chromoly steel. Okay, and then for the first step, we will cut the chromoly steel tubes to design specification. In the second step, we use TIG welding to join the tube accurately, and then we will heat treat the frame to release internal strands. And then for the fourth part, we will perform surface treatments such as the anti-corrosion coating or the powder coating. And then for the last part, we will assemble additional components such as bracket, hanger, and headset.
Okay, now I'm going to discuss about the limitation and the challenges for all the components. So for the first component is the pedal, which is the recycled nylon. It is inconsistent material quality due to varying source of recycled nylon. It also has higher moisture absorption leading to dimensional instability. So for the second component, which is the gear exchange, which is the fiber reinforced biopolymer composite. It has lower strength and stiffness than metal counterparts. It has environmental degradation such as UV and moisture that can reduce performance. So for the third component is the tires, which is the thermoplastic elastomer. It has lower heat resistance, which may cause soften in hot weather. It has less traction and grip, especially on wet surface. For the fourth component is the bicycle frame, which is the chromoly steel. It chromoly steel increase weight, which may affect performance, especially in racing or climbing. It also prone to rust if not properly coated. So the last part of our presentation is the conclusion. So in the conclusion, material science is the key of modern bicycle designs. The ensuring the parts like tire, frame, gear and chains and pedals meet its specific performance needs. Such as we discussed just now, tires must be required flexibility, durable rubber frames, and needs a lightweight strength, chains, and demand fatigue resistant metals. And for pedals, it should be balanced strength and weight. So this highlights how proper material science improve efficiency, safety, comfort, and product lifespan. As a material and technologies evolve, bicycle will continue to become more and more sustainability and high performing and user oriented.